This presentation focuses on the Quebec Bridge collapse of 1907, one of the most tragic failures in civil engineering history. Known as the bridge that collapsed twice, it highlights lessons in engineering oversight, communication, and structural analysis. We will walk through its vision, the design flaws, the ignored warnings, the collapse itself, and what engineers learned from this disaster. The Quebec Bridge was envisioned as the longest cantilever bridge in the world, spanning 1,800 feet across the St. Lawrence River to connect Quebec City. It was designed to carry heavy railway traffic and symbolize Canada's expansion and progress. This ambitious vision set the stage for both innovation and tragedy. One of the key mistakes was underestimating the bridge's dead load, the weight of the bridge itself. Critical members, especially the one labeled A9L, were designed too slender to carry the actual stresses. Because modern tools like finite element modeling didn't exist, engineers relied on simplified calculations, which turned out to be dangerously inaccurate. Even before the collapse, there were warning signs. The on-site engineer, Norman McClure, noticed distortions in the steel members and reported them. He sent a telegram to consulting engineer Theodore Cooper, who recognized the danger and instructed construction to stop. But the message arrived too late. The bridge collapsed only minutes before workers received the order. On August 29, 1907, the Quebec Bridge collapsed while still under construction. The central span had not even been added yet. The failure was caused by compression buckling of the slender members. Tragically, 75 workers lost their lives that day, making it one of the deadliest bridge construction accidents in history. Beyond the technical flaws, this disaster was also a story of project mismanagement. Overconfidence, lack of adequate peer review, and poor communication between engineers in the field and consultants in distant offices all contributed. It shows that even the best designs can fail if project oversight and communication break down. After the first collapse, reconstruction began in 1913 with a stronger design, but tragedy struck again in 1916 during the lifting of the central span. It fell, killing 13 more workers. Finally, in 1917, the bridge was completed successfully. The structure still stands today, a reminder of perseverance, but also of the price paid in human lives. From the Quebec Bridge, engineers learned powerful lessons. Never ignore signs of distress in a structure. Over-design is always safer than marginal design. Field engineers must be empowered to act, not dismissed, and structural stability must be quantitatively validated, not simply assumed. These lessons still guide engineering practice today. Next, we'll look at the Sampung department store collapse of 1995 in South Korea, a very different type of disaster. Unlike the Quebec Bridge, which failed from miscalculations, Sampung collapsed due to greed, corruption, and unauthorized design changes, leading to one of the deadliest peacetime building failures.